We're going to be plugging in things and taking a look at what how exactly these parabolas look like. So what we're doing is we're making a table. Now, when I write down f of x, basically I mean a function as it depends on x, and that function is x squared. So if I'm asking you what is f of 1, that's saying, well, if I replace the x with 1, that would be 1 squared, also known as 1, because 1 times 1 is 1. So if x equals 1, f of x is equal to 1. What is f of 0? Okay, well that's pretty simple. 0 squared equals 0. Alright. What is f of negative 1? Alright. Well, the question is, what is negative 1 times negative 1? Because that's what negative 1 squared means. Basically, I'm plugging negative 1 into this x squared term over here. So I'm asking, what is f of negative, or what is negative 1 squared? So that's negative 1 times negative 1, also known as positive 1. That would be here. What is f of 2? Alright, so f of 2 is equal to 2 times 2, which is also known as 4. I think that we can fill out the rest of this table. If I plug in x equals 3, that would be what is 3 squared? 3 times 3, which is 9. Negative 2 times negative 2 is also known as positive 4. Because the negative 2 times the negative 2, the negatives cancel, you end up getting positive 4, and this would also be positive 9. So if I were to graph this, and I think that my graph got cut off at the bottom over here, so this is the x-axis, and this is the y-axis over here. At x equals 0, y equals 0. I see that corresponding right there. At x equals 1, y will go up to 1. So this is another point on my graph. At x equals 2, y goes up to 4. At x equals 3, y goes up to 9. So that would be way up here. Then also the reverse is true. So negative 1 goes up to positive 1, negative 2 goes up to positive 4, and negative 9 goes up to positive 9. Or negative 3 goes up to positive 9. Hence, I'm getting this curvy shape looking thing right here, which we call a parabola. Notice how a parabola looks the same on the right hand side as it does on the left hand side. It's kind of symmetric like that. Also, it has this curved shape because, well, it's not a line. Because if it were a line, I would expect that the next point over here would be, it would go like this, and I would get a line like that, but that's not what I have. I have a thing that increases in an odd way as I go further out in the x-axis. And you also know how these tables govern this line. Now, I can use a graphing calculator, and I just been over to desmos.com or whatever, and I can plug in x squared, and there we go. I have my curvy parabola shape. So if I go out to 3, I'll go up to about 9. Yeah, about there. And if I go out to x equals, I don't know, I can go out to x equals whatever and get y equals blah blah blah. Alright. So let's see. The shape of x squared looks like a u. The function x squared is called a parabola. The lowest point on the parabola, well, there is a lowest point on this parabola. It would be this point right here. If you look at the words here, the only thing that would probably be called is a minimum. It's the lowest point. It's the minimum. The minimum point on the parabola is called, alright, so we use this word, we use this word, we use this word. It's actually called the vertex. I know that there isn't a pointy part of this parabola. It's a U-shaped thing. But I guess it would be, I could kind of define it as the pointiest part of this parabola. It would be where this is the vertex over here. It'd be like the bottom of that gulch, or the top of the hill if it were an upside down parabola. Now the vertex passes through this point called the axis of symmetry. Now remember how I told you that this thing looks symmetric on the right side as the left side? Well, we define a parabola as having an axis of symmetry So it's basically on the right hand side it looks the same as the left hand side at this particular x coordinate. And in this case the x coordinate is x equals 0. That's not always the case, because I could have a parabola that looks like this, and in that case the axis of symmetry would be right about here. But this is called the axis of symmetry. Alright, I'm going to go through the negative x squared one for you really quickly. That one's pretty straightforward. If I have f of x equals negative x squared, basically what is f of negative 3? So that would be negative 3 squared, which would be negative positive 9, because negative 3 squared is positive 9, but I tack on this extra negative over here, so I have negative 9, I'll have negative 4, negative 1, 0, negative 1, negative 4, and negative 9. I'll graph that, and basically what I have is an upside down parabola. Let's talk about the vocabulary of this thing real quick. It's actually pretty straightforward. There's me failing at learning how to connect the dots when I was a kid. Actually, I'm writing on this computer tablet and it's actually really tough. This graph looks like an inverted U. It's still called a parabola. This thing doesn't have a minimum. There isn't any lowest point that it goes, because it goes on forever in the negative direction, but it does have a maximum. There is a highest y value that this thing can reach. So it has a maximum. The answer to this question is maximum. The maximum point of this thing is called a vertex. In this case, the pointy part of this thing occurs at the maximum, which we still call the vertex. And it passes through the x coordinate, is still called the axis of symmetry.